Hello auditors, my name is Isheng. Today I'm going to teach you guys how to solve Ethernaut's Delegation Challenge using Brownie Python. Firstly, I will explain how the contract works, and then we'll move on to the exploits. Let's begin. Okay, now we are at the Ethernaut's Delegation Contract Challenge. You can see this is Contract Delegate and this is Contract Delegation. So let me explain the contract. We have a state variable of owner here and initialize owner of the deployed contract. And then we have a function pawn here which basically just changes the owner to message or sender. So what this means is that when you call the function pawn, the person who called this will become the owner. And then over here we have the contract delegation, same thing, state variable, and then we have this variable of delegate contract. Then over here we initialize the contracts instance. So we get the instance of this particular contract and then put it as delegate variable. And then the person who deploy this particular contract will be the owner. Over here we have a fallback contract which basically is similar to our previous challenge, which is basically is the first challenge. So fallback is a function that when you send either or call a function that is not in the particular contract, this will be triggered. Now, over here you can see this interesting line of code. So bool results, so basically get a boolean of whether it is true or false, and address delegate call message.data. So over here, basically since this has been initialized, we get the delegate instance and delegate call whatever message data that we input here. So what delegate call actually is that this has this particular illustration which I will further explain using this particular graph. So you can see that over here in this article, first contract A invokes the safex function via delegate call over here. Then the delegate call overrides contract B storage with the storage of the calling contract, which is storage A. Then next, the function executes and you can see that the contract B storage bar to storage slot 0. So when this function makes a reference to variable bar, it once look again as slot 0. However, slot 0 is now reference pointer to full, so task footer is set to 5 and bar remains out of scope and is untouched. So let me explain how this works using a illustration painting here. Okay, so what this does is that when you call delegate call, it actually doesn't affect contract B. So what this means is that this bar won't be affected. Then it is like a contract A is just have additional function of set to 5 here, but it's not written in this contract here. So now let me move on to explain how do we exploit this code. Okay, I'm sure you guys know how to actually initialize Brownie. If for those who do not, I'll just reiterate again from the previous video. So basically, you just run Brownie init in directory that I've created. So I've created delegation directory. Then what this does that you actually initialize this directory with these 5 subdirectories. Actually, no, 6 subdirectories. And then afterwards, you can create a brownie-config YAML file. So what this does is that when you run Brownie script, you will actually check this configuration file before running your script. And then we have some simple configuration here. We have dependency and this remapping. So what this does is to basically just import the safemath library, which I'll further elaborate later. And then we have this .env to this .env, which basically tells Brownie to get environment variable via the environment file. And then lastly, we have these wallets from key to private key just to get our private key in our environment file. So over here, we have our own private key and we have this export web3 Infura project ID API key. So why do we need this is because that we will be using Gorelli network, and since we are using Gorelli network, Infura is a node provider for Gorelli, so we can just use Infura API to interact with our contracts. So let me reiterate over here. So since this delegate call is actually just calling this function, it will not affect these other function as this other variable as well, or any other function. So delegate call is literally just like an additional function in your code. So for example, over here is your code, then we have this additional function over here, just added on, however, is not directly written over here. Okay, now let me further explain message.data and how do we exploit it in this fallback function. So basically what message.data is that within this message.data, there are some several fields. We have from, to, guest, limit, and data. And message.data allow the contract to have access to these particular fields. So what is message.data? Over here, there is some simple example. So over here there is strings, bytes, and array in this particular function as well. Then when you input your message.data, there is our first parameter or first byte in our message.data, which is method ID. So what this is like our function name. Then afterwards we have our address and other location of byte data, so on and so forth. So if you have arrays or strings, there will be more and more. And then you can see that the strings, bytes, and array all have their size data appended to the end of message.data. Moving on. So how do we exploit this? It's very simple. We actually just pass in our encoded pawn, which is basically our method ID here. So that delegate call will actually call this function signature. So let's just run this. Since we are using delegate call, so we will be just calling the pawn function. Wait, give me a moment. Let me just on my tools, my painting tool. Oops. Okay. So basically, again, we'll call this pawn function as though it's our own. And you can see that transaction has been confirmed, and let's submit our instance. And we should be able to complete this challenge easily. And you can see that we have successfully completed the challenge. So if you like my tutorial of delegation on Ethernaut Challenge, please hit the subscribe button and hit the like button. Thank you for watching and have a nice day.